Okay, so we're going to learn a little bit about numbering systems. Our own numbering system has 10 different symbols in it, and that's why we call it base 10. They go from 0 to 9. But what that means is when we want to express a value larger than 9, we have to create basically a new placeholder whose value is larger than the original. So the placeholder on the left has a value of 10 at this point, and the placeholder on the right has a value of 1. You all know this. So in order to write the number that is larger than 9, we write a 1 on the left and a 0 on the right, and the idea here is that this 1 has a value of 10 and this 0 has a value of 1. And after that we can continue to write more numbers, right? 1, 1 means that this 1 is 110 and this is 1, 1. And I can say 1, 2, which is 110 and a 2, all the way up to 9 tens and 9 left over, in which case we find ourselves in a little bit of a problem again. We couldn't possibly write a number larger than this without adding yet another placeholder, right? So now I have a placeholder whose value is 10 tens, or 100. And then this is still 10. This placeholder is still a 1. And so I say the next number is a 1 here, having a value of 100, and the next two numbers are 0. And we can continue. And we can obviously go and add new placeholders on the left for as long as we want. But notice that the value of these placeholders are always powers of 10, right? This is base 10, and so each new placeholder is going to be a new power of 10. This, I know you all know this, but this is going to help you understand the way that binary works. Binary works in exactly the same way. The only problem is that we only have 2 digits to work with. We only have a 0 and a 1 because computers basically only understand 2 states. They understand the presence of electricity, which we represent with a 1, or the absence of electricity, which we represent with a 0. And so we end up sequencing 1s and 0s together in order to communicate different values to the computer. So in binary, the first 2 numbers are the same as the ones that you're familiar with, right? We start with a 0, which means 0, then we go to a 1, which means 1, but then we immediately have run out of space, right? We have to immediately create a brand new placeholder on the left. So therefore, since the next number's value is a 2, its placeholder here is a 2. So I put a 1 there to represent that I have 2, and that means I need none left over in the 1s column. So this is how many the placeholder on the right is worth. So this has a value of 2. In order to create the number that has a value of 3, I simply say that I have 1, 2 and 1, 1. But notice that I've already run out of room, and so I need another placeholder in order to write a number with a value of 4. So I have 3 placeholders. I assign this placeholder a value of 4, and I put a 1 there, and that means I've got 4. So I need 0 2s and I need 0 1s. In order to write a 5, I'm going to have 1 4, no 2s, and 1 1. So essentially, the numbers 1 through 10 in decimal, our numbering system, look like this: 0 1 2 3 6 7 8. Well, I'm going to stop there. Basically, they look like this in binary. 0, 1 is the same, 2 is 1 0, 3 is 1 1, 4 is 1 0 0, 5 is 1 0 1, 6 is 1 1 0, 7 is 1 1 1, and notice I've run out of room again. So in order to express an 8, I create a new spot and add 3 zeros. And this pattern can continue indefinitely. Alright, so we're going to practice translating decimal numbers into binary and binary numbers into decimal. So for this exercise, we're going to say that this 200 is in decimal, our numbering system, and we're going to convert it into binary, and we're going to say that this series of 1s and 0s is in binary, and we'll convert it into decimal. Alright, so how do we convert 200 into binary? I always like to write out the binary number as if it's write out the binary number in all of its placeholder values. So the idea is that you know that the binary number is going to have a 1, a 2, 4, an 8, You write out these placeholder values until you get to one that is too big, basically. Ooh, sorry, this is so messy, but I'm not very good at this iPad stuff yet. All right, so notice, I'm writing out all these placeholders, and then I get to 256. Now, if I were to put a 1 there at 256, I'm already bigger than my target value, right? So clearly I don't want a 1 there, and I don't want anything bigger than this. So I'm just going to delete all that. So let me go find the eraser here. We don't need this placeholder value, but clearly that means we do need a 128, right? But by putting that 1 there, I've allocated 128 units. So if I have 200 kind of unit values to allocate, I've already taken care of 128, which means I only have 72 left to allocate. Well, if I have 72 left to allocate, it'd be smart for me to put 1 there by the 64. That would take care of 64 more of them, and so now I only have 8 left to allocate. Well, if I only have 8, I certainly don't need a 32, I don't need a 16, and I should probably put a 1 there by the 8. And now I've taken care of the 8, and it's reduced down to 0. So I can put zeros here in the rest of these placeholders. So the number 200 in decimal is the same as 1, 1, 0, 0, 1, 0, 0, 0 if we were to express it in binary. And by the way, notice that there are 8 1s and 0s here. That makes it, if you were to talk about it in the terms of a computer, it makes it a byte. Each of these little 1s or 0s represents a bit, and so 8 bits makes a byte, so that's kind of nice. Okay, so now let's turn this binary number into ordinary decimal, or our numbering system. This is actually a lot more straightforward because we just use the approach that I already taught you. We just kind of count out what the placeholder values for each of these numbers is. So we know that this is a 1, we know this is a 2, we know this is a 4. This has a placeholder value of 8. That's the 0, this is the 1. This has a placeholder value of 16. This has a placeholder value of 32. So I have a 32, I have a 16, and I have a 2. So let's just go add those up. I've got a 32 plus a 16 plus a 2. And this is going to come out to be an even 50, it looks like. And that's it. That's all you got to do.